Hello from Oslo, Norway. My name is Amela Karahasanovic and I'm coming from SINTEF, which is one of the largest research institutes in Europe located in Norway. I'm going to present the work on user involvement in the design of machine learning infused systems. This work has been done by an interdisciplinary team of mathematicians and human interaction experts from SINTEF. You see the names of my colleagues who contributed to this research here. Machine learning is more and more used in different domains like image recognition, banking, healthcare. The machine learning algorithms can, for example, successfully recognize a husky, although it is rather similar to a wolf. We believe that machine learning algorithms can be used in complex, time-critical, safety-critical domains, such as air traffic management. If we want to be successful in doing this, we need to involve air traffic controllers in the design and the evaluation of the algorithms. But the question is, how to do this? How to involve end users in the design of machine learning infused systems in time-critical, safety-critical domains? Well, like all amazing constructions in the history, it has to be done by adding its different parts step by step. Air traffic controller's job is to direct aircrafts on the ground and through controlled airspace to organize and expedite the flow of the traffic and to prevent collisions. In their job, they use highly automated and very complex decision support tools with several algorithms behind. Such systems have several parts. One important part of future systems that will be used by ATCOs is a dynamic airspace configuration algorithm. Briefly, this algorithm will produce sectorizations that dynamically adapt to a traffic situation. It consists of two parts, a machine learning part and an optimization part. Machine learning part will perform indexing that will be used as input for the optimization that will produce new sectorizations, and then these sectorizations will be presented to air traffic controllers. To facilitate user involvement, we developed a prototype enabling end users to evaluate different versions of ML algorithms. We then conducted an online study consisting of 3 iterations. Each iteration was organized as a recorded Microsoft Teams meeting. The same 3 domain experts participated in all 3 iterations. These experts were also the intended users of the system under development. The experiment sessions were led by a facilitator and assisted by a secretary taking notes. Notes were mainly scores and the comments. The developers of the tool and the algorithm participated as silent observers. The facilitator assisted the participants and collected scores and other feedback, both during and after each scenario and session. Each session was followed by internal debriefing meetings for the facilitator and observers. Observer notes, recorded sessions, and chats were processed by a quick content analysis using open coding. All findings, scores, comments, observations, content analysis, and lessons learned were summarized in a common document after each iteration and used in the further development of both the algorithm and the prototype. The participants, the setup, the protocol, the air traffic, and the data collection methods were the same for all the 3 iterations. The algorithm was enhanced through these iterations. This was based both on the findings from earlier iterations and the machine learning algorithm's ability to learn over time. The web-based interface of the prototype also evolved a lot. The changes were caused both by feedback from the participants and the characteristics of the scenarios. In the first 2 iterations, we had a larger number of shorter scenarios, and in the last one, we had 2 scenarios with 6 hours of traffic. Because of that, we needed functionality of the prototype that was slightly different. So, how the prototype looked like. What was the minimum functionality enabling controllers to see if a sectorization is good enough? Here you can see the prototype that we used in the last iteration of the study. It consists of 4 main parts. The first part you can see here. It is a map showing the sector configuration in use and the air traffic in each sector. The map can be shown in 2D or 3D and may be zoomed and panned. In 3D mode, the map can be tilted to better view the vertical extent of each sector. The second part is here. It is a sector selector. It may also be used for hiding and showing individual sectors on the map. The end user may also use it for switching between the different sector configurations in the scenario. Here is the third part. It is a statistics panel showing the entry count and occupancy for the sectors and the configurations that are currently selected. The fourth part is the control panel, setting the time and changing the speed of the simulated traffic. As you can see, it is much more complex than, for example, a tool showing pictures of dogs and wolves and enabling you to say that this is a dog or this is a wolf. Let's now move to findings and the concluding remarks. Well, would I recommend to develop a special tailored and rather complex prototype and to conduct an extensive iterative evaluation with end users? The answer is yes, definitely. I would recommend this. The feedback from the domain expert was valuable for the development of the algorithms. The end user sessions enabled us to determine if some optimization objectives were missing, identify the relative importance of each optimization objective, estimate if the workload caused by proposed sector configurations and the change is acceptable by air traffic controllers. The end users evaluated the sector shapes as good and workable, but they also identified some shapes that would lead to higher workload for the controllers. For example, they identified the closeness of the traffic to sector borders as an important objective. This is shown here. This objective was neither described in the literature nor discovered during the requirement analysis. Further, we identified the relative importance of different optimization objectives relatively to each other. What was interesting was that the opinions of ATCOs differed. Next time, we will show the results of the evaluation to the participants and discuss these results in plenum, as we need not only to find the algorithms giving the best sectorizations, but also to understand why some sectorizations are better than others. What are the lessons learned on the user involvement process? The first one is the importance of explaining the role of machine learning and how it works. We explained the architecture of the system and the role of machine learning to the participants in the beginning. But this wasn't enough. They were used to rule-based systems and it was difficult for them to change the mindset. We need to develop examples explaining better machine learning in complex domains. Further, one needs to communicate clearly the goal of the evaluation. We said to the participants that we do not evaluate the functionality prototype but the algorithm. Still, many comments were related to the prototype. This is related to the next issue. It is not easy to find the appropriate maturity level of the prototype. This is ongoing research. Our future work includes exploring other alternative ways of user involvement and exploring other ways of explaining capability of machine learning algorithms. Thank you for your attention. It's time now for questions and comments.